Functions are used to map inputs onto outputs. The notation f of x is used to represent a function of x. The set of inputs is called the domain, and the set of outputs is called the range. For example, this diagram shows how the function f of x is equal to x squared maps 5 values from its domain to 5 values on its range. The roots of a function are the values of x for which the function of x, f of x, is equal to 0. If the input of a function x can be any real number, the domain can be written x(er), where e means is a member of and r represents the real numbers. To find the value of a function for a given value of x, say a, we write f of a and we substitute in a wherever we have x in the function. To find the roots of a function, we set f of x equal to 0. And to solve a function given a value of a or another function, we set the value of the function either equal to a or to the function and solve. For example, f of x is equal to a or f of x is equal to g of x. Firstly, we're asked to find f of minus 3 and g of 10. So we need to substitute minus 3 into our function for f and then 10 into our function for g. We'll start with f of minus 3. So we get f of minus 3 is equal to 3 times minus 3 plus 6. So we're replacing x by minus 3, which we can simplify to give us minus 9 plus 6, which equals minus 3. If we then look at g of 10, again we're going to replace x with 10 in our function for g, so we get g of 10 is equal to 3 multiplied by 10 squared minus 8 multiplied by 10 plus 2. Again, we can simplify this to 3 times 100 minus 80 plus 2, which gives us 300 minus 80 plus 2, which is 222. For part B, we need to set f of x equal to g of x and solve. So we get 3x plus 6 is equal to 3x squared minus 8x plus 2. We now have a quadratic equation, so to solve this we need to make it equal to 0. So 3x squared minus 11x minus 4 equals 0. We can now factorise this. So we get 3x and x equals 0, which gives us x equals minus a third and x equals 4. So here for part A, we need to write g of x in completed to square form. So to do this, we need to take out first a factor of 2. So g of x is equal to 2x squared plus 8x plus 27. And then we can complete the square on our bracket. So we get 2x plus 4 whole squared minus 4 squared plus 27. And then we can simplify our square bracket, so 2x plus 4 squared minus 16 plus 27. And now we can multiply both things in our square bracket by 2, which gives us 2x plus 4 squared minus 32 plus 27, which we can simplify to give us our final answer of 2x plus 4 squared minus 5. We can find the roots by setting g of x is equal to 0. So g of x is equal to 0 means that 2x plus 4 squared minus 5 is equal to 0. We can now rearrange this. So 2x plus 4 squared is equal to 5, dividing by 2 gives us x plus 4 squared is equal to 5 over 2. And if we take the square root, we get x plus 4 is equal to plus or minus square root of 5 over 2, giving us x is equal to minus 4 plus or minus the square root of 5 over 2. Using our completed the square form for part A, we know the minimum value is minus 5. So for part C, minimum value is equal to minus 5. And this occurs when our bracket is equal to 0, so x plus 4 is equal to 0, giving us x equals minus 4. Firstly, we need to write this equation so it's easier to factorize. So if we let y equal x squared, then y squared equal to x squared squared, which is equal to x to the power of 4. This means that we can rewrite f of x as f of x is equal to y squared minus y minus 12. And we're asked to find the roots of the function, which means that f of x is equal to 0. So we get 0 is equal to y squared minus y minus 12. And we can now factorize this to get 0 is equal to y minus 4 y plus 3, which tells us that y is equal to 4 or y is equal to minus 3. However, the question is in terms of x, so we need to find x now. But we know that y is equal to x squared, which means that x squared is equal to 4 or x squared is equal to minus 3. X squared equals 4 gives us two solutions. X is equal to plus or minus root 4. So x is equal to plus or minus 2. However, we cannot square root minus 3. So x squared is equal to minus 3 gives us no solutions. Now complete textbook exercise 2A, page 26, doing questions 1, 3, 2, 4, 5 and 6, and then have a go at questions 7 and 8. Complete all of these questions and come and get help if you're struggling with them.